Okay, so in this lesson, we're going to be talking about some more index laws, and all these laws concern raising powers. So let's go through our learning intentions. We want to be able to simplify expressions in which the index is 0, to understand the meaning of an expression like b raised to the 4 in brackets to the power of 2, to be able to simplify expressions involving powers of powers, to be able to expand expressions where a product is taken to a power. So like this right here. Okay, so the first index law that we're going to go through in this lesson is going to be this one right here, which states that a raised to the 0 is equal to 1 for every value of a except 0. So this right here tells us that when we have a number and we raise it to 0, it's going to be equal to 1. So let me repeat that. When we have any number and we raise it to 0, the answer is going to be 1. All right, let's go through an example here. And this example is going to prove as an explanation as to why this is true. So I want you to write this down. I want you to write down 5 raised to the 3 over 5 raised to the 3. Now, we can immediately answer what this is going to be. The answer is going to be 1, because whenever your numerator is the same as your denominator, you know that your answer is going to be 1. And let me just give you an example. Don't write this down, but let me just give you an example of this. If I had 2 divided by 2, my answer is going to be 1, because 2 goes into 2 once. What if I had 47 divided by 47? Well, my answer again is going to be 1, because 47 goes into 47 once. What if I had 2,949 over 2,949? Well, that's going to be 1 as well, because my numerator is the same as my denominator. So it's going to be equal to 1. Okay, let's rub that out. What we can also say, if we were to rewrite our question, so 5 to the 3 over 5 to the 3, is according to index law 2. So in our last lesson, we learned about index law 2, which tells us when we're dividing things with the same base, we can subtract the indices. So in this case, because we have the same base here, we could go 5, 3 minus 3. So when we have the same base, we can subtract the indices. Now, 3 minus 3 is going to be equal to 0. Okay, so this is very important now. Let's just draw a little partition here. We have said 2 statements here. We have said 5 to the 3 over 5 to the 3 is equal to 1. And we have also said 5 to the 3 over 5 to the 3 is equal to 5 to the 0. So both of these statements are true. Well, if 5 to the 3 over 5 to the 3 is equal to 1, and 5 to the 3 over 5 to the 3 is equal to 5 to the 0, what that means is 5 to the 0 is equal to 1. And that is proof, kind of a proof of index law, this one right here. It's proof of this index law that any number raised to the 0 power is going to be equal to 1. So whenever your index is 0, your answer is going to be 1. Okay, let's go through some examples here. It says simplify the following expressions using the index laws. So if I have 7 to the 0, my answer is 1. If I have 194 to the power of 0, my answer is 1. If I have x to the power of 0, my answer is 1. If I have k to the power of 0, my answer is 1. Pretty straightforward stuff. Whenever the power is 0, your answer is 1. All right, let's come over here now. So this right here is a little bit different. If we were to write this in expanded form, it would be 4 times a to the 0. Now this is going to be 1, and then I have that times by 4. So my answer is going to be 4. So you just got to be careful here. This a is raised to the power of 0, but this 4 isn't. Now, when we come here, because I have brackets, this whole statement is raised to the power of 0, which means the answer is just 1, because the whole thing is raised to the power of 0. Over here, if we were to write this in expanded form, it would be 5 times x squared y to the 5 to the power of 0. So as you can clearly see here, this 5 is not raised to the power of 0. It's by itself. So it's going to be 5 times 1, and then the answer is 5. So that's your answer there. Okay, let's keep on going now, and you're just going to be careful of it. You're going to say, hey, this b is raised to the 0, but this 10 isn't. So this is going to be 10 times 1 plus 5 to the 0, which is 1. 10 times 1 is 10, plus 1. Your answer is going to be 11. We come over here, and you'd say this 4 is not raised to the power of 0. This x is. Then we times 8x. Now this y is raised to the power of 0, so we times that by 1. So I'm going to get 4 times 1 is 4, times 8x times 1 is 8x. So my answer is going to be 32x. And that's my answer right there. Let's keep on going. Here we have 3 to the a raised to the 0. So the whole thing is raised to the 0, so it's going to be 1 times, this b isn't raised to the 0, but this c is, so times that by 1, plus, here I have 7xb to the 0, so it's going to be 7x times 1. All of this is just going to be b. Then I'm going to plus, this right here is just going to be 7x. So that means that that's my answer. Now, hopefully you can see that, writing times 1 all the times is kind of a waste of space, isn't it? Because 4 times 1 is just 4. So a better way to kind of do your working here is just like this. You would look at this one right here. Let's see if I can center this. You'd look at this one and you'd say, hey, this is 4, x to the 0. So that's just going to be 4. Then you'd come here. Here, this is 6, b to the 0, then c. Well, this b to the 0 is just going to be 1, so it's going to be 6c. This is going to be 24c. That's your answer. Here, this is going to be 9 times, this whole thing is raised to the 0, so it's just going to be 3. So the answer here is going to be 27. This one right here, well, this whole statement is raised to the 0, so it's just going to be 1. 7 times 1 is just 7, plus this whole statement is raised to the 0, so it's going to be 1. 7 plus 1 is 8. So as you can see in your working, there's no real need to put in these times ones everywhere. It just kind of makes it a bit messier. All right, let's keep on going. So now we come to index law, the next index law that we're going to look at here. So this index law tells us that when we have brackets b to the m, close brackets n, what happens is that we multiply the m and the n together. So m and n multiply. So a power of a power can be simplified by multiplying indices. Okay, so let me give you an example of this. So I want you to write this. If I had a to the 2 raised to the 3, so these brackets are important here. Okay, so what exactly does this mean? What this means is I have a to the 2 times a to the 2 times a to the 2, because it's raised to the 3, so that just means I have 3 of them all multiplied. Now, according to index law 1, which we saw in our last lesson, when we're multiplying things which have the same base, what do we do with the indices? Well, we plus them together. So I'm just going to write this down again. So I'm just writing that down, is equal to. So here, I'm just plussing together all the indices. So I'm going to get a, 2 plus 2 is 4, plus 2 is 6. And there you go. So according to index law 1, we can say this. And now you can notice something. 2 times 3 is equal to 6. So instead of doing this and then adding them together, a far better way to do it would just to do this. So I'm going to rewrite it again. So I'm just rewriting this each time just to show you. A quick way to answer this would just go 2 times 3, which is equal to a to the 6. So what I'm doing there is I'm multiplying my powers. So what I'm doing here is I'm just multiplying my powers to get the answer. All right, let's go through a few examples here. So this is example 2, multiplying indices. Simplify the following expressions using the index laws. Large numerical values like 5 to the 4 should be left in index form. So that's just telling us that we don't have to evaluate really big numbers. Okay, so this right here. So remember, when you've got these brackets and you've got a power to a power, you multiply your powers. So this is going to be 2, 3 times 5, which is going to be 15. Here, we're going to go x 2 times 8, which is going to be x to the 16. Here, this is going to be k 8 times 3, which is going to be k to the 24. So we're just multiplying our powers. All right, our final index law that we're going to look at. Here we have brackets x, y, m equals x to the m, y to the m. Expressions involving powers can be expanded. So as you can see here, I have this m on the outside, but what it looks like is happening is I'm just expanding it in so that each of these is raised to this power. Okay, let's go through another example here. I want you to put brackets 2a, close brackets, raised to the third power. Now, we know what this is going to look like in expanded form. It's going to be 2a times 2a times 2a. Now, if we really wanted to, I'm just going to rewrite this again. If we really wanted to, we could write this in even greater expanded form. We could say that this is 2 times a times 2 times a times 2 times a. So what I've done there is I've just put the multiplication sign between each of those. Okay, let's rewrite this. So what can we say here? Well, I have 1, 2, 3 2's. So that means I have 2 raised to the 3. And I have 1, 2, 3 a's. So I have a raised to the 3. Now, hopefully you can see that it would have been a lot quicker, instead of doing all of this, to simply go on, let's raise 2 to the 3, and let's raise this a to the 3 as well. So its expressions involving powers can be expanded. So I'm just kind of like putting it inside. I'm expanding it out in that sense. Okay, so let's go through some examples here. And these are the last examples we're going to go through. All right, simplify the following expressions using the index laws. Large numerical values like 5 to the 4 can be left in index form. So this right here, the way that we're going to answer this is we're going to expand out this 2. So 5 is going to become 5 to the 2. And then remember here, we're going to use that other index law that tells us that we can go 3 times 2. So I'm going to end up with 5 to the 2 is 25. Then this is going to be x to the 6. We come over here. This is going to be 2 times 4. U to the 2 times 4. Then I multiply it. Here, this 7 is going to become a power of 2. So 7 to the power of 2. And then this u is going to become 5 to the power of 2. So 5 times 2. 5 times 2. This is going to be u to the 8 times 7 to the power of 2 is 49. Whoops. And this is going to become u to the 10. Now this is where we have to use our other index laws. Remember, when you're timesing things with the same base, the indices add. So it's going to become 49 u to the 18. Let's come over here. This 4 is on the outside, so we just leave it there. And this is going to become x to the 21 times 2. This is going to become x to the 12 because 4 times 3 is 12. So as you can see, I'm just multiplying these indices. Now I'm going to go 4 times 2 is 8. And because these are the same base, I'm going to add these together. So it's going to be 21 plus 12, which is going to be 33. Okay, let's come down here now. So again, we're going to do the same thing. We're going to expand out this 10. So it's going to become 3 to the 10, x to the 20 over, this is going to become x to the 6. Now we're going to use index law 2 here, which says that when we're dividing and we have the same base, the indices subtract. So it's going to be 3 to the 10, x to the 14, because 20 minus 6 is 14. Over here, we have 8h to the 20. This 2 is on the outside. 3 times 5 is 15. Now, we also have to cancel out this 8 and this 2. Both of them are divisible by 2, so that's going to become 1. This is going to become 4. And then I'm going to subtract my indices here, so it's going to become 4h to the 5. Now we come over here. We're going to expand out this 4. So I'm going to get 2 to the 4, w to the 24, because it's 6 times 4, over 2 to the 2, w to the 2. What I'm going to do here is I'm going to subtract these indices because I have the same base of 2. So I'm going to get 2 to the 2. Then I'm going to get subtract these indices because they have the same base w. So it's going to be w to the 22. And 2 to the 2 is just 4. So that is going to be my answer. Okay, so that is everything we needed to go through. So we went over 3 more index laws in this lesson. And hopefully you feel comfortable with using all of them there. Now, what I've also done is the last page here, I've just left as all the index laws that we covered. So this is the one in which you're adding the indices, subtracting the indices, when you're multiplying the indices, when you're expanding the indices, and when you have an index of 0, it's equal to 1. And I've provided a little example of each one if you ever do forget. So I think that would just be a helpful reference page. Okay, so with that being said, hopefully you found this lesson helpful, and I'll see you in the next one.